In this video, we want to evaluate the integral of the product of sine x, cosine x, and we'll see if we can do it at least 3 ways. And we'll start by doing this. There's a trig identity that tells you if you have 2 times the sine of x, cosine of x, that's the same thing as sine of 2x. That'll make the integration easier. So in other words, put a 2 here in front of the product. Now that's legal, as long as I put a 1/2 here in front, because 1/2 times 2 gives me the same thing I started off with. So this then, using that trig identity, is the same thing as the sine of 2x. Now this makes it easier to integrate. So the integral of sine of 2x is minus the cosine of 2x. And then derivative of 2x is 2, so we have to put this out here. Then we have the constant of integration. So multiplying this out, then this is 1/2 then times the 1/2 there. So this is actually minus 1/4 here then. Because of this 2 here, this is cosine of 2x plus the constant of integration. This is your final answer using this method here. Now there is another identity that tells you you have the product of sine x, cosine x. You can write this as a sum of sine plus sine. But if you use that formula, it pretty much comes out the same thing as what we have here. But that's another way to do it. So what I'm saying is that you can take this here and write this as a sum of sine plus sine, using these angles x and x here. We'll leave it that way. Another approach you can do is this. We can let u equal to sine of x, then du would equal to the derivative of this sine, cosine of x dx. And then we can use this substitution here. So this is going to equal 2, and then this is my u. That's my substitution, so this is integral of u, and then cosine of x dx here is the same thing as du. Now we just integrate with respect to u using the power rule for integrals at 1 to the exponent. It gives me a 2. Divide the coefficient by that value, that'll be 2 here, plus the constant of integration. Now we go back to the original variable here, so for the u, we put sine of x, quantity squared, over 2, plus the constant of integration. And this would be another answer using this method. Now it doesn't look like the first answer, but it's just in a different form. I could actually take the first answer and use some trig identities and rewrite it so it does look like this one. But that's another answer. And of course you can compute the derivative of this expression and show that it gives you this. Because if you take the derivative of this, 2 comes out in front, so that cancels the 2. Subtract the 1, gives me a 1 there, and then the derivative of sine, yes, cosine, I get that same integrand. So that checks out. You can check your answers to confirm. And the next way actually is very similar again, back to the same type of method, but in this case we'll let u equal to cosine. And the answer is going to look different, but it will be a solution to this integral. You can check again by computing the derivative of the answer and showing that you get the integrand. So this will be du equal to derivative cosine is minus sine of x dx. So I'll come back over here then and got the integral then. This time u is cosine, and notice here, let me rewrite this. I'm going to multiply both sides by a negative here. So I'll put negative here. Multiply the right side by a negative, it just gives me sine of x dx. So here we go then. For the cosine of x, I got u. And for the product, sine of x dx, that's right here. That's minus du. I'll put the minus in front here, minus du. That's pretty much the same thing as the previous one here. Integrate, I get minus here. Using the power rule for integrals, add 1 to the exponent. This will give me a u squared, and then divide by that value. That's 2. Plus the constant of integration. Then we go back to the original variable. So this will be a minus. And u is cosine of x. This will be cosine of x, quantity squared, over 2, plus the constant of integration. So the third solution then is negative quantity cosine of x squared over 2, plus the constant of integration. Thanks for watching, and we'll see you next time.